Okay, we're officially ready to start. Thanks everyone for joining today. My name is April Barton. I'm one of the math teachers. You may have Karen Whitehead or Janae Russell. There's a couple of us. So you can get a hold of me if you have any questions at this email, april.barton@graduationalliance.com. Or you can reach your own teachers using your dashboard. You can send them chats or their email will be there as well. So today we're going to cover quadratic graphs. This is in Algebra 1 Semester 2. We're going to take time for questions. We'll talk about sine, cosine, and tangent, and then take some time for more questions. My whiteboard keeps going out on me though, so I'm going to try and use the program's whiteboard. So I'm going to switch this up really quick. Okay. So hopefully you should be seeing a whiteboard. Can everyone see that whiteboard that should be showing? I don't usually use the whiteboard. Okay, yes. Thank you for your response. So, okay, good. So, we're starting with quadratic graphs again. This is from Algebra 1 Semester 2. So a quadratic function is any function that has this little 2 on the x. If it's x squared, then it's quadratic. You can have anything else. You can have numbers, you can have an x, you can have another number. As long as it has that x squared and nothing bigger, you can't have an x cubed or x to the fourth, then this is a quadratic. When you draw the graph, every quadratic graph is a U-shape we call a parabola. And your parabola can be facing up, your parabola can be facing down, can be on the right side of the graph, or you could be on the left side of the graph. As long as it's a U-shape, then this, so you cannot see anything. So we have two people who can see the whiteboard. Okay, so I am writing and no one is seeing the writing. That is a problem. Okay, let's try and fix this. Okay, so the whiteboard in the program's not working. Thank you guys for letting me know. I'm gonna try, since the original whiteboard I tried wasn't working, let me try a different whiteboard. Okay, let's try this again. So, there should be a new whiteboard. Now can you guys see me right? Okay. So it should say y equals 2x squared minus 3x plus 4. Looks like it is. Okay, great. I'm glad we got that worked out. Anytime something like that happens, please let me know. We want you to be able to see. So this is a quadratic function. I'm going to have to recap since you couldn't see what I was pointing at before. This is a quadratic because it has a squared. You can't have a higher exponent. We couldn't have a 3 or a 4 or anything. As long as they're squared, this is a quadratic. You could even have just squared, like just x squared is a quadratic. Or you could have squared with a number but not another x. There's a lot of different versions. As long as they have squared, it's that quadratic. And when you draw the graph, it makes a U shape, which we call a parabola. You'll probably hear that word a lot in the lesson if you're working on Algebra 1 Semester 2 or when you make it there. So the U shape can be facing up, the U shape can be facing down. On our parabolas, there's a lot of information we need to know about it. Let me erase this all and draw a little more accurate picture. Sorry, it's hard to draw with the mouse, so that line was not straight. Welcome to our new students who have joined. Right now we're talking about quadratics. So on our quadratics, this parabola, there's a lot of key pieces of information we can ask about. The first thing is the vertex of the quadratic. This is the bottommost point, or if the graph is flipped upside down, then it would be the topmost point. If our parabola looked like this instead, the vertex is the very top point. And so if you're asked to find the vertex or name the vertex, you can actually give a coordinate. Anytime we work in this coordinate plane, then we need to be able to name a coordinate. So every coordinate is always x and y, and the x-axis is this horizontal, y is this vertical. So from the center, which I'll sometimes call the origin, from that center point, we need to decide, well, how far right or left do I go? And how far up or down would I need to go after that to get to the next spot? So for this vertex, we're going right. So how many spaces do I count to the right before I'm lined up directly above that vertex? You can either respond by typing into the chat, or if you wanted to unmute yourself and answer, then you could answer that way. How many spaces to the right do we count? Okay, good. Have a couple answers, and you're both correct. 3. If we count from the center, it's 3 spaces. A common mistake people will make is they'll say 1, 2, 3, 4, but you don't count till you make that movement, which all of you guys did well. So the x value of the vertex is 3. And then from there, we're counting down. If we count down, now we're going to go the negative direction. And now we've gone 2 spaces. So 3, negative 2 is the coordinate of the vertex. So that is one key piece of information from our quadratic or our parabola. A second key piece of information is where it crosses the x-axis. These are called the x-intercepts. And it's literally where your graph crosses the x-axis. So we can also label these as actual coordinates. And for both of these, we only go to the right. We don't go up or down. So no matter how many spaces we've moved, the y value is going to be 0. We don't go up or down. We didn't make that movement. We count that as a 0. So the first one's easier. Where did we end up on this first x-intercept? Where's the x again? So the x is, there's a couple of ways the x is involved in this coordinate plane. The x-axis is this horizontal line. I'm going to highlight it in purple. This is the x-axis. The x-coordinate of a point is how far right or left you count from the center. So from this origin, I count 2 spaces over, and that gives me the x-coordinate. If that didn't answer your question, let me know and see if there was something I missed. Hopefully I covered what you were asking. So for this first coordinate, yes, we are still in Algebra 1. If you have a different question from a different course, in about 5 minutes, we'll stop talking about quadratics and you can ask a specific question from whatever course you're working in.
Okay, thank you.
Yep. So the first x-intercept is 2, 0. You'll notice this second one is kind of in between. When it's in between, if you've drawn it by hand, you just kind of have to guess. You can also use a graphing calculator. So a good online graphing calculator, if I type it correctly, let me try this again. Desmos.com is a pretty good online graphing calculator. So the graph I was drawing, I didn't give an equation for. I was just trying to talk about the parts of it. If I have a quadratic function, which is not going to match the one I drew because I'm just making this up. Let's make it lower so it has an x-intercept. Oops, too low. Okay, so if you use a program like this, or if you have your own graphing calculator, they'll all have a way to actually highlight the intercepts. So if it's in the middle, you can either use a graphing calculator to find it exactly, or you can estimate. So this, what's a good decimal for this point here? And again, you could answer in chat or by unmuting yourself and talking. What's a good decimal for where we cross the x-axis at this point? No responses yet. I'll keep an eye out. So you count to the closest tick mark, and then we kind of estimate how far we are in between. So 250, you've got to make sure you start from the center. So from this origin point, we're counting 1, 2, 3, 4 tick marks over. So 450.
Yeah, I was getting there.
Yes. It's hard because I'm drawing this by hand, so it's hard to see these tick marks really well. So some of it is probably just, you know, it's hard to draw this by hand in the first place, and it's hard to draw with a mouse. That makes it worse. Okay, so 4.5, we're about halfway in between, so we put that 0.5 on the end.
So what is that called though? What x is that? Is that an intercept?
That is also an intercept. This graph has 2 x-intercepts. It has the x-intercept 2, 0, and it has the x-intercept 4.5, 0.
Okay, thank you.
Mm-hmm. Quadratics can have 2. We did have another question about absolute value. In one more minute, we're going to switch from quadratics to questions from your guys' classes, and I'll talk about it then. So a quadratic could also have just one intercept, one x-intercept. If it just barely touches the x-axis, the only x-intercept on this one would be -3, 0. Or if it doesn't cross at all, if it's just out in the air, it never touches the x-axis, it can have no x-intercepts. So we're running out of time on this topic. If you do still need more on it, there's still things like domain and range and y-intercepts. If we have more time at the end, or if it's one of your questions from your courses, we can address it further. But I want to make sure we have enough time for question time, since we do have a couple of questions. So Lillian asked about absolute value equations, and I think Mark had a question that he hadn't specified yet, but it sounded like he wanted something to be talked about from your guys' courses.
Actually, I'm fine with mine. I just started Algebra 1 a couple of weeks ago.
Okay.
It's just a matter of remembering definitions at this point.
Yeah. It can help to like take notes and write them down as you go.
Oh yeah, I am. Thanks.
And then Lillian, you have a question?
Yeah, so I'm definitely having the same issue as Mark. But another thing is I need help with the, what was it? What did I say it was? The
Absolute value equation?
Yes, I finished the course and then I got stuck on the final, and so I failed the final with just a couple questions left. And so I guess I just need a little help with a couple of the different things, like absolute value equation is one of them.
Okay. So let's do a couple absolute value equations. So absolute value equations are weird. There's a lot of steps to them. So the first step is you always want these absolute value bars alone. You'll get questions where there's some numbers outside. So if there are numbers outside, you do have to move those first before moving on. We're going to start with this left problem, though, where there's no numbers outside, so we're ready to go to our next step. And what's weird about absolute value equations is once you get these bars alone, you actually have to split this into two separate equations. The reason why is because absolute value is a weird function. Oh, Lillian, do you mind if you mute yourself unless you have a question, just so we don't have background noise?
Sorry.
That's fine. It happens all the time. Just, it's hard when there's already enough background noise at my office. So, absolute value is weird because there's actually two possibilities. If whatever's going on inside here equals 3, the absolute value is the distance from 0 to the number 3 on the number line. If you can move 3 spaces from 0, that's one option, the positive 3. But you can also move 3 spaces from 0 to the left, so negative 3 is a second option. So when you take this, you take the first option and say, well, one possibility is I equal 3. The second possibility is I'm going to equal negative 3. Because 3 and negative 3 are both 3 spaces from 0. Once you've split it up, you have your first equation and a second equation. These are two separate problems to solve now. And I don't want to write the whole word equation, so EQ stands for equation. These are two separate things that you're just going to handle like normal equations now. So if you only had x minus 5 equals 3, what opposite operation would you use to move the 5 to the other side?
I have no clue. Division? I don't know.
Okay, so division is opposite of multiplication. And right now we don't have any multiplication going on. We look at the variable itself and say, well, what is the number doing in reference to the variable? Okay, so we're still having some confusion. I'm going to get rid of some stuff so we can see that was a separate example. We'll do one that's a little more complicated later. Sorry, the erasing's not that great on this whiteboard. Okay, I'm going to go back. I'm going to just clear the whole board. We're going to start again. Got a lot of confusion going on. I'm going to write this problem down really quick.
I'm sorry to be so complicated. I just don't get it.
That's fine. That's what these are for. If you're confused, I'm happy to start over, try it again. That's part of the process. So let's back up to just the definition of absolute value. So before we even get to the equations, we need to know, what does it really mean to take the absolute value of a number? So if I'm going to take the absolute value of 4, these bars tell us we want to look at the distance this number 4 is from 0. So from 0 to 4, how many spaces is that?
Three. Well, I'm sorry. 5.
That's too far. So when we start at 0, we count the movement as actually one space. You don't say,
Okay.
so not 1, 2, 3, 4, 5, just 1 space, 2 space, and Alicia said it too, 3 space, 4 spaces. So the absolute value of 4 is 4 because it's 4 spaces away from 0. What if we look at negative 4? Absolute value of negative 4, how many spaces away from 0 is negative 4?
It'd still be 4, wouldn't it?
Still 4 spaces.
Right.
Okay. So these two numbers, the 4 and the negative 4, give you the same answer. They both gave you 4. Okay. So Alicia said she's doing good so far. Lily and Mark, are you guys still following along? Do I need to do more?
I'm catching
No,
on.
I'm fine. I just haven't gotten to absolute values here, so
Yeah.
I'm learning.
Okay. Okay, I just want to make sure we got this down before now moving on to the next part. Okay. So when you get a variable involved, it's a lot more complicated. Ugh, I hate the erase feature on this. Sorry, I wanted to keep the number line, but get rid of everything else. Come on. Close enough. I'm going to leave that last one because it's not erasing for me. So if we get a variable involved, we're saying, what number could we put in here so that when you put that number in, you get out the answer of 4? So what number could we put in that spot so that when you get your answer is a 4?
Okay, so is it plus, minus, addition, subtraction? What is it that
The
we
very,
put in the box?
right now it's just one number. What one number could you put in the bars to
4.
come out? 4. That's one possibility. X can be 4. Okay.
Square? I don't know.
So, well, 4, if we put an absolute value of 4 in, we get 4. There is only one other number. What other number can you put in the variable spot and you still get 4 is your answer?
Negative 4?
Negative 4. So Alicia said 4, Mark said 4. The second one is negative 4. Those absolute value bars literally gave us 2 options. There's really just 2 answers. X could be 4 or X could be negative 4. We basically just split this up into 2 separate things. One is you could get a 4, one is you could get a negative 4. So let's take that one step further. Forgot I had a back button. I'm going to just back button this. Okay, so now we're going to take it one step further. So Melisha said, so it doesn't really matter. Yes and no. It's not that it doesn't really matter, it's that you have to consider both options. One answer is 4 and one answer is -4. Both of them work. So now we have absolute value bars of x plus 3. We have more going on in here. We can't just say, I know the answer is 4 because we have more going on. But we can, good, one answer is a 1. If you put 1 plus 3, that gives you 4. What if it's too complicated to figure that out in your head? You're right that it's a 1. What if we had like 5x plus 0.73 equals the 4? We need a process that works every time.
Could you change it into a fraction?
You could change it into the fraction. That would help some people, not help some people. Go ahead, what were you gonna say?
Oh, no, either a fraction or decimal or find, I forgot the name for it.
Percentage?
Drawing a blank.
But yeah, all good ideas. If there's a lot more going on, sometimes different formats will work or help. And I'll show a problem like that in a minute.
That's what I'm looking for.
Oh, simplify.
Simplify it?
It depends on the problem. It's a little more complicated because there's just so many versions it could be. So sometimes you would need to simplify. What we need to do with an equation, though, is we need to come up with a pattern we can follow every time so that we can go through and solve it. So that pattern is, we know one of these needs to equal the 4. We know one of these should equal the +4 because if that whole inside stuff becomes 4, you get an answer of 4. Do we have a question? Sorry, someone unmuted themselves, so that's why I paused.
Are you saying that both answers, okay, because there has to be 2 answers, that it would be 4 and -4, or is there still another answer?
Nope, just those 2. So one answer has to be the 4, one answer has to be the -4. But that variable being involved means this x itself isn't actually 4. We already know that for this one, x equals 1. That you can figure out logically. You know 1 plus 3 is 4. This one's a little harder on the right side. You can't just logic it as easily because we don't know what number could we put here so that when we add 3, we get -4. So if it's a little harder like this.
-7.
Okay, so -7, that is correct. What if, again, it's just too hard for us to figure it out? We need a process that works every single time. So that process is how we solve equations. When you have an equation, you have the 2 sides. You have the stuff to the left of an equal sign, the stuff to the right of the equal sign. And our goal is to get rid of any numbers on the same side as x. We don't want this 3 here. We want x to be by itself. So we choose to do opposites to get rid of them. What is the opposite of addition?
Subtraction.
Subtraction. We want to do that because 3 minus 3 is 0. We picked that opposite to get rid of that 3. The x didn't disappear, but we got 3 minus 3 is 0. The number on the other side has to also be minused by 3. With an equation, what you do to one side, you have to do to the other side. So from that, -4 minus 3 is a -7, just like Mark had figured logically. So does that make sense how we got to the -7? Alicia says she's okay. How about everyone else?
Yeah, I think I got it.
Okay. So let's make it one more step complicated. We're running into, we were going to do the next topic of sine, cosine, and tangent, but since this was a direct question from you guys, I'd rather finish up this absolute value equation topics, make sure we get it to where you guys are comfortable with it. So let's make this one step more complicated. So absolute value of 3x minus 1/2 equals 8. Now, first of all, most of you probably don't like working with fractions. That's just everyone doesn't like fractions. So instead, let's change this into a decimal. We talked earlier, Mark said, what am I going to do with a fraction? Okay, and so Melisha, you're stuck on the fractions. Well, one way to deal with fractions, depending on what it's asking you to do, if you're only adding and subtracting fractions, we would want to do a different process. But if you're working with it in an equation, change it into a decimal. Okay, so we'll work on some fraction stuff then after we finish this problem. So to change a fraction into a decimal, you just plug it into a calculator. The fraction bar is really division. 1/2 is 1 divided by 2. That gives us 0.5. So instead of 1/2, we changed this to our decimal, so it's a little easier to work with. Now this absolute value stuff comes into play. We're going to split it into our two options. This time, instead of having a 4 on the right, we have an 8 though. So our first option is just the 8. One of the options is you're 8 spaces away from 0 at positive 8. What's our second option? What should I put it equal to for our second?
-8.
Yeah, you are exactly correct. -8. -8 is also 8 spaces away from 0. Just like positive 4 was 8 spaces, or sorry, positive 4 was 4 spaces away from 0, and negative 4 was 4 spaces away from 0. Positive 8, -8. So what I remember is one option is positive, one option is negative. If you forget why, that's the most important part, is how do we do it? One's positive, one's negative. Then we solve our equations. So right now we're only going to focus on this left equation, and we have our two sides to that equation where we need to do our opposite operations. So if we're subtracting here, even though it's a decimal, we really only care about the subtraction. What's the opposite of minusing something?
Addition.
Addition. So we choose to add 0.5, but what you do to one side, you have to do to the other. We have to also add 0.5 on the right. On the left, it cancels. We picked it specifically that way so that when we did the opposite, it really comes out as 0. So we can just cross it out. The other piece is just going to come down. And then on the right side, that's where we actually do the addition. 8 plus 0.5. And you can use online calculators. If you want to have it separate, you can download a calculator on your phone. Lots of calculator options. You are welcome to use them all through the course and on the finals. So that's 8.5. So now the next opposite is a little harder. This 3 is just touching the x. There's actually a math operation going on here. Is the 3 adding, subtracting, multiplying, or dividing to the x? How is it interacting?
I'm assuming it's multiplying.
Yes. All mathematicians assume everyone knows that. They're like, I'm too lazy to write out that this is 3 times x. Everyone already knows that. So once you know that, then you pick the opposite. Our opposite of multiplication is to divide. And again, this cancels. This time, instead of going to 0, 3 divided by 3 is 1. But we don't care if there's a 1 in front of a variable. 1x and just x is the same. So again, we just cancel. But the other side is the important part. Some people don't even write the opposites on the left. They just say, I'm getting rid of the 3. I need to do 8.5 divided by 3. 2.8333. Let's round to the nearest tenth. So I'm going to say 2.8 only. Okay. So there's our first answer. Now we have to do that whole process again with the other side. The good thing is we do the same opposites. We're going to get different numbers, but our first opposite is still to add 0.5. So I'm going to show you another option. Some people, like I said, don't write the work on the left. They just say, I know this is going to cancel. So I'm going to cancel it out. And I know I have to do the opposite, which is add 0.5. But this time, since it's a -8, let's go to our calculator again. -8 divided, nope, sorry, wrong one. Add 0.5. Okay, got to make sure this is all in the right order. Okay, plus 0.5 is -7.5. So our answer came out different. We still added that, different answer. And then we still do the opposite of divide by 3. Again, if you don't want to write it on the left, you know, I cancel that, do the division on the other side. And then -7.5 divided by 3 is -2.5. So now we have our two answers. So 2.8 and -2.5. Okay, glad we're getting there. Looks like Melisha left. I was going to take her question on fractions, but she is no longer here. So does anyone else have a specific question from their course they want to ask?
I have a really quick question. It's not specifically for the course, but I spent a lot of time avoiding algebra. So when I was younger, and some of the simple terms I never learned. So I wonder if you had a link for some place where I can get a list of mathematical terms, such as the correct name for parentheses and all that stuff, because I skipped a lot of that stuff.
I know a couple sites I use, but usually they're whole lessons. So while I am finding something, we also, someone joined on their...
If you want to just send me the URL, that's fine too.
Okay. So I can send you a site, something like this, where it's alphabetical. I'll see if I can find one where you could also like type in a term so that you don't have to look it up every time. Or you can always just try Googling it too. So I'll find a couple
I was trying to find something that had like maybe a picture of the actual mathematical action, and then along with it the term of what it is, because some of these, you know, some of them are the instructions or what you're supposed to do to the equation I'm not understanding because I don't know the terms.
Okay.
And that's kind of part of the problem.
I will do some research then and find
I
a site.
appreciate it. Thanks so much.
It would help. So Mark, you don't have your last name written down. What's your last name so I can find?
Okay, hold on a second.
You can type a private message to me if you want, or you could send me an email and
I'm not
say
worried
I
about
was
it.
investigate. Okay.
My life is public. I don't really care.
Okay.
There you go.
Okay. That way I send it to the right Mark. We have
Right.
lots of them in the program. So, and Lillian also was interested. Maybe I guess I'll just send it out to everyone too. That might be a good idea.
Because, you know, like when you were saying, are you there?
Yes. Can you hear me?
Okay, so didn't know if it was paused. When you say like absolute value, I haven't even gotten to that yet, and I don't know what the absolute value sign is.
Okay. Okay. So I will do some research on that. And then there was a question from, it just says Ret3. I don't know your name. Did you want to type out your question, or do you want to unmute yourself and ask a question? It sounded like you were wanting to ask a question from your course.
Can you hear me?
Yes.
Okay, if you hear babies screaming in the background, please forgive me.
Okay.
Okay, my question is more so on the quadraticals and binomials.
Okay.
Specifically with, give me 1 second so I can get to my notes.
Mm-hmm.
Factoring out the the binomials, and also doing the factorization when they're just in the parentheses, like 2x, take away 8 in parentheses, and then 6x plus 7, like something like that, where they're in parentheses. They're already, like it's a backwards FOIL, I guess you would say.
Okay. Okay. So factoring. So factoring is in Algebra 1. When you get to it, factoring is a fancy type of division. So when you're working with mathematical expressions, this is called a binomial because there's 2 of these. Like bicycle has 2 wheels. So this is a binomial, and if you want to factor it, you want to do the opposite of distribution. When you distribute something, you multiply it into both terms. Since x and 4, one's a variable, one's a number, so variable being the letter, then they can't actually combine together. So when you multiply, you have to do it separately. You do 3 times the x, 3 times the -4, and you get out a binomial. Well, what if you need to go backwards? What if you start at the binomial and want to go back to that set with the parentheses? So when you do this backwards, it's easiest to do what's called prime factorization, when you break it down. So we want to look for numbers, and I'm going to start with the 8. We want to look for any numbers that multiply to be 8. So what are 2 numbers that multiply to be 8?
2 and 4.
2 and 4. So now we're done with the 8. We broke it down. But if these numbers can break down, we also break those down. What can the 4 break down to?
2.
2 times 2. Now notice I didn't even try to break down the 2 because 2 is considered prime. The only thing that multiplies to be 2 is 2 times 1. And when that happens, you would just be doing 2 times 1 over and over and over again. So we don't break down a number when the only thing that can be broken down to it is the number times 1. So that's why I didn't start with this 2. It doesn't break down anymore. So we have 2 times x plus 2 times 2 times 2. So from our first term, this first group before the plus sign.
I'm sorry to interrupt you. Can't you list that like 2 to the 3rd power or something?
You could. In some situations, you might want to. So you could write this 2 to the 3rd. For the process we're doing, that is not helpful. So even though it's true, it doesn't help you factor to do that. Because what we want to do is we want to look for, from this first group and from the second group, what do they have in common? What's something that's in the first and in the second group?
2.
2. The only thing they have in common is one of these 2's. So when we distributed, that 3 that was initially in front got used 2 times. So it was here twice, but it was originally only written once. So it's going to look right now that something disappeared, because instead of writing these 2 that were the same, they're going to be only written once in front of that set of parentheses. So it looks like we had 2 things and it merged to become 1, but that's because when you distribute, you do end up writing it twice, and now we're going backwards. So instead of writing twice, we're going from 2 back to the 1. Everything else stays inside the parentheses. There was nothing else in common, so it just stays there. And we do want to simplify back to no multiplication anymore. Instead of writing 2 times 2, we want to finish this off to say x plus 4. So that's how we do backwards distribution, how we factor, and it'll be called greatest common factor because we found a common number when we broke it down. So any questions about this factoring process? And we do have someone who unmuted yourself. If you're not asking a question, make sure to keep it on mute. Okay. So if no more questions, okay, so no, got it, good. No more questions about greatest common factor. So we're going to take this a step further. There's other kinds of factoring. Okay, Greta, good to know. Yeah, when you join with your phone, it doesn't always give me your name, so I wasn't sure who you were before. Okay, so factoring, when you're doing backwards FOIL, is a little bit different. So again, we need that process. What does it mean to FOIL? When I say the word FOIL, what is that? You could also call this multiplying binomials. Did you have a question, Greta? And you got unmuted again. I just want to make sure I'm not talking over you.
I'm going to answer your FOIL question, the first, the last, the inside and the outside process.
Yes. Yep. So the technical term is we're multiplying binomials. We use this little mnemonic, FOIL, to remember how to do it. And as Greta said, first, outer, inner, last. That's what this stands for. So what it means is when you multiply, you do the first from each parenthesis times, so the first from the first parenthesis times the first from the second. These are the first of each parenthesis. Then the O stands for outer. That's looking at the entire shape. So again, we're using lots of these terms 2 times. This is the second time we used that first X. Then we do inner. So -2 times the X is the inner. And the last. So again, last and last are these 2 numbers only. So this is just the process. Now we need to actually do the multiplication. X times X, just like we had the 2 times 2 times 2, and we said, well, that could be written as 2 to the third. This is one of those cases where we want to do that. X times X doesn't really become anything, but we say, well, since there's 2 of them, we're just going to write X squared. 4 times X is 4X. -2 times X is -2X. And -2 times 4 is -8. So then there's one more step on these FOIL problems, which is to combine like terms. The 4x and the 2x only have x's, so they can combine together. 4 minus 2 is a 2. So again, that is one process that's actually also a lesson in the course, but the specific question is, how do we factor? So factoring, again, is going backwards. We're going to start with x squared plus 2x minus 8, not knowing anything else. We don't have this original FOIL problem. We know we want to make it look like that. So how do we do that? If we have no other information than the x squared, the 2x, and the negative 8, how are we going to get it to look like this?
Reverse its function.
Basically, we're going to reverse its function. So we have to figure out, well, how do we do that? Okay. So greatest common factor is not relevant here. Greatest common factor only works if you're trying to do that backwards distribution. If we broke everything down, let me just show you really quick. If you try greatest common factor, you'd say, well, that's x times x, that's 2 times x, this is 2 times 2 times 2. You would do that factor tree again to do it. I'm kind of glossing over this because I'm just trying to show you, if you look at all 3 terms now, they don't have anything in common for all 3. If this was 2x squared, then they'd all have a 2 and we could greatest common factor. But since there's 3 things, they would all have to have something in common. So we want to look for, if we only know a 2 here and a negative 8 here, this is what we know, how do we get back to the negative 2 up above and the 4? So we know the 2 and the 8. We want to figure out, well, how do we get this 2, negative 2, and this 4?
Subtract? I don't know.
Okay. So it's kind of a weird process. When we got the 2 came from the 4 minus 2. So in part, you're right. We subtracted 2 numbers, and it became the 2. The negative 8 we got from doing multiplication. Negative 2 times 4 is negative 8. So we multiplied 2 numbers, and that gave us the negative 8. Now in general, not everything's going to subtract, so we're going to stick with how it will work in general. Most of the time we're going to do this plus. So basically we want to find 2 numbers that add to be the middle term, add, and multiply to be the last. This negative 8 is the last term, middle. So when you go through that process, when you say, okay, what 2 numbers add to be the middle term and multiply to be the last, sometimes it's just guess and check. Like, let's try one that doesn't work. If I said 1 times negative 8, that does multiply to be negative 8, but we would go check the addition part and say, oh, 1 plus negative 8, that gives me negative 7. I wanted a 2, but instead I came out with a negative 7. So that didn't work. So then you try a new pair of numbers and say, okay, well, I know 2 times negative 4, that gets me negative 8. 2 plus negative 4 is close. 2 plus negative 4 is negative 2. So we're almost there. When that happens, we can just change the signs. If we say negative 2 plus 4, now we come out with both of these numbers.
So you can use any of those numbers in the equation to be able to do that?
Yes, any 2 numbers that work with both. We already knew the numbers because we'd done the FOIL, but this time I'll give you a problem where we don't know the numbers. So when you do that, you do finish the problem by writing it out. We know x squared we got from x times x if we follow this process back up, which means it was the first in each parenthesis, and that's going to hold true. We put the x in the x, and then the two numbers we found, -2, +4. Okay. So lots of explanation there. Let's go and actually just do a problem from scratch. Sometimes the explanation helps, but it also helps to just see this is how we do a problem. I had to come up with a problem really quick. +18. So this one, we have no clue what ones were, oh, I didn't realize I'd gotten a message. Oh, she left anyway. Shoot. Megan couldn't hear. That must be why she left. I was too much in the middle of trying to explain things.
Is that an 18 or is that?
That is an 18.
Okay.
That's just my bad handwriting because I'm writing with a mouse. And that's a 9x, just in case the 9 looks too weird. So x squared plus 9x plus 8.
And absolute values. All right.
Yeah, no absolute values on this one. So we want to follow that same process. We want to find the two numbers that add to be the middle and multiply to be the last. Oops, that's last. So add to be the middle, multiply to be the last. I usually write the workout to the side and have my blank spaces so I can put in numbers and see which ones work. But it is easiest to start with the multiply. There's less things that multiply to be 18. So what are two numbers, any two numbers that multiply to be 18?
Two times 9.
2 times 9. That is definitely true. 2 times 9 equals 18. But it has to fit both. Is 2 plus 9 going to give us the correct number when we add?
No.
No, it's going to give you 11.
No. Give you 11. Not what we want. So not those. And if it's a particularly long problem, you might want to like write down below, I tried 2 times 9, didn't work. So now, what are any other numbers that multiply to be 18?
Well, it's pretty much going to have to be something multiplied by 2.
Not necessarily.
6 times 3?
6 times 3. I guess you could say 6 was multiplied by 2, you know, 2 times 3 is 6. But in general, we want just two numbers at a time. We don't want to break it down like we did that factor tree.
Oh, okay.
Yep, this one is not a factor tree, which is weird because greatest common factor is a factor tree. So this one we're just looking for two numbers only.
Okay. I was confused because I thought the numbers had to be that were in the equation, not where 6 come from then.
Because 3 times 6 is 18. It literally comes from the fact that these two multiply to be 18, and
so they don't both. So both the multiplier doesn't necessarily have to be from the equation.
Correct.
Like 3.
Yep.
That's not in the equation itself. You can use another number.
Mm-hmm. Yes.
Okay.
The last.
See, I was trying to work with the numbers given. Like I can't do it.
That makes sense. You wouldn't be able to. Yes, they will not always. On the last problem, we had 2 in the equation and 8, and then our answers were 2 and 4. So one of them was there, but the 4 was not. It doesn't have to be in the equation. It just was coincidence that the last problem had a common number.
Got it. Because I was thinking the last problem, I'm like, so every problem's got to work like this?
Yeah. Nope. Yeah, that would very, very much limit what you could do. But once you find the two numbers, final answer is just writing it in. We know that x squared gives 1x for the first and 1x for the second. And then you just write the +3, +6. The order does not matter. I could write x plus 6 if you got 6 and wrote the 6 first and then wrote the 3 second. Doesn't matter. Still the same answer. And I lost track of time. I didn't realize we were almost at, well, we're out of time. If you want to stay a few minutes, I can't do very much longer because there's another class after for science. So they'll need the account. But there's one more kind of problem that is a little bit longer of a process, so it's good to talk about. I've got to make a problem really quick though, so it comes out so we can actually factor it.
So that was all that problem needed? There was no other, nothing to do after that?
Yes, that problem was done.
Okay, that's where I was probably going wrong. Huh, thank you.
Yeah. The first problem, I had so much explanation, it looked longer. The second one was just, this is how you go through it. But once you get it in the 2 parentheses, you are finished.
I just want to comment to Mark real quick before we end this.
Mhm.
I commented in the group chat a URL to something that's helped me a lot throughout the whole algebra semester 1.
Mm-hmm.
I private messaged him, but I don't know if he's got it or not. But I did.
I'm still trying to figure out how to work this, so I'll check that in a minute.
Okay.
Could you actually send that to the whole group? I'd love to take a look at it too.
I really appreciate it. I don't know who you are.
Yeah. So it's called Symbolab, and so what it does is it's like an online tutor. You put in the equation, and it will tell you exactly step by step how to get to the answer. And now if you're using it for cheating, just don't get on there. It does give you the answer, but it teaches you step by step how to get to that answer. And so that's been really helpful to me
That
for
sounds really cool.
understanding.
Are you Lillian?
Yes,
Okay, thank you, Lillian. I appreciate it.
no problem.
Yeah, thank you so much for the resources. It's good to hear about new stuff because most students need or want resources like that.
Sorry about that. I'll hush now.
No problem. No, I really appreciate the comment. Okay, so last type of problem. This one looks the same as the last problem, but is very, very different because of the number in front. The last problem was very straightforward. Find those numbers, you're done. This one, since there's a number in front of the x squared, the process is a lot longer. And I'll only be able to go through the process once. There's videos on it in the lesson, or I can find a link showing the process again. It's a long process, so you're probably going to want to see it more than once, but it's still called factoring. They all have the same title of factoring because they're all technically the same type of process, but this one's a lot harder to go through. So the first step is to times the first number times the last. I'm going to say F times L for first times last, which is negative 30. And then it's going to have a step similar to what we just did, but then again, it's going to change off and be different after that. So now we want to find two numbers that add to be the middle still. So our middle is still the negative 7. That didn't change. But now we want them to multiply to be the negative 30. So on the last problem, it was just the last term. This is a lot different. We have to do that first step to figure out what do we want to multiply by. So what are two numbers that multiply to be negative 30? Any two numbers that multiply to be negative 30?
6 I'm sorry, 5 and 6.
5 and 6. One of them does have to be negative. Mark, what were you going to say?
Oh, same thing.
Same thing. Okay. So then we check. Does the 6 plus the negative 5 give us a negative 7?
No.
No. Okay. 6 and negative 5 are out. Any other numbers? What are two numbers that multiply to be 30?
10 times 3.
10 times 3. Again, one of them needs to be negative.
Negative 10 times 3.
Now we're getting it. Now we're getting it. I think.
Yep. Good. So that does give us the negative 7. You are correct, Mark. These are the right two. So that was the same
Cool.
as the last process. Next, it's going to be very, very different. Like I said, when there's this number in front, the 6 in front of the x squared, or any number in front of the x squared, makes this process different. We're going to rewrite the negative 7x as negative 10x. That was the first number we found, plus the 3x. That was the second number we found. So we still have 6x squared here, but then we're going to rewrite this as negative 10x plus 3x. So like I said, very different so far. Now we want to greatest common factor the first two. So only the 6x squared and the negative 10x, we want a greatest common factor, which is that factor tree process. And we're running out of time, so I'm just going to kind of rush through it. The 6 is 2 times 3. The x squared is x times x. And the 10 is 2 times 5. And this time it's only an x. So now, what do they have in common? What's the same in the first group as in the second group?
2.
2. Anything else?
X.
X. So that common piece goes in front. We have 2 and x in common. Then everything else goes inside. We have 3x minus 5 left over. Minus sign does still come down. So we've greatest common factored the first two. Now we greatest common factor the last two. So these two. You'll notice when we break it down, there's nothing really else to break it down to. When that happens, oh, I got a message from the teacher mentor saying I don't have to feel too pressured. She emailed the other teacher to not log in yet. So we should be okay to at least finish this problem. So this is a problem. When we're greatest common factoring in this process, we must have something in common. If there's not, so this is one of the very, very few cases, we do want to write this with a 1. If they're not going to have anything else in common, we want to at least have the 1 in common. So most of the time we say, I don't need that. This is one of the very few cases where we say, yes, I do, because we need that common piece. When we write it, we also have to keep the sign from above. This is a plus 1. Most of the time when we do greatest common factor, if it's positive, we don't put a plus sign in front. But since there's already some stuff here, we put a plus 1. So now what goes in the parentheses? What's left over after we take out the 1?
5x, or x take away 5.
The x take away 5 and the 3 in front.
Oh, okay.
Yep. Don't forget, even if it was before the 1, it still needs to be involved. So the last step is to write your answer. And technically, we're actually greatest common factoring again. if we look at, go yellow, I'm running out of colors here. If we look at that first thing as one entire thing and the last part as one entire thing, what do they have in common?
They have their numbers are the same in common, yeah.
Yeah, that 3x minus 5, this whole parenthesis, is in common. So that common parenthesis, we're writing first. This is the common part. Common. Nope, sorry, that should be 2 M's. What's left over? What was not in common?
2x and the 1.
2x and the 1. So those two parentheses, just like the other problem we were doing backwards FOIL, we got to 2 parentheses. This problem is also backwards FOIL, it's just a lot more complicated. This is the answer. So a process like this, like I said, there's so many steps. You'll probably want to watch. This video will go up on the YouTube channel, so you could rewatch this if you need more practice. In the lesson itself, there should be a video on it. But don't worry if you're still a little confused by it. It's just a tougher process. You have to see it and practice it a couple of times. So we're definitely out of time. I got to get off so the other teacher can get on. Thanks so much for your participation today. This was a really great one. Sometimes, yeah. We do this every week. So if you have more questions, I'll be here again next week. And if in between you have questions, you can send me chats or you can email me at, let me write it out. So.
Yeah, and thanks to Lillian for that link. I'll go check that out right now.
That's no problem. You guys have a good day.
You too. Yeah, and if you need to email me, you can email me at this address. Thanks and have a great day.
You too. Bye-bye.
Bye.